Okay, we're going to continue second installment of this Chapter 6 presentation. Just as a recap, last time we talked about simple interest versus compound interest. So that was simple interest, and then there was compound. And they're both interest. What is interest? Let's get back to basics, make sure we're all on the same page here. Interest is the representation of the fact that there is a time value to money. That's what this whole chapter is about, the time value of money. People say time is money. They usually mean by that if you're a lazy bum, you're wasting time when you could have been making money with that time. They often could mean, or they also could mean, that time is money in the sense that with money, over time, your money can make money. How is that? Well, if you lend your money to someone else and you charge them a rate of return for the value of their money while they have your money, while they use your money, you charge them a charge of time for using your money, then your money will make money over time. And we call that interest. The contract, and it is a contract, is that the lender is giving the borrower the use of money, that the borrower presumably will use the money to make money for themselves, which gets us to another expression, that it takes money to make money. So people use your money in order to make money, and what they do is they basically are sharing their profits with you, but they're doing it when they borrow in a way that's saying that I promise to pay you a certain fixed factor, a fixed determinable amount of money, and it'll be a rate of return of X% of your money, which is interest. So when that is paid, regardless of the profit made by the borrower, the lender makes money on their money. Presumably the borrower, let's say the borrower is a bank, and they're borrowing the money at 6%, presumably the borrower, which is paying 6% for the use of that money, will make at least 8% on the money that they've borrowed. And that difference between paying 6% to borrow money and making 8% on it, that spread, that 2 percentage point spread as we call it, is where the profit is made by the bank. And that's a typical bank spread, 2 points. If the bank spread can be 2 percentage points like that, where they make 2 points more than the cost of borrowing the money, the banks will make money, because in that 2-point spread over a lot of money will be enough profit to cover administrative costs, expenses, and all the costs of running the bank, plus a decent amount of profit. So that's the basic contract, if you will, that exists between the lender and the borrower. We use the concept of interest to do a lot of things for us in the business world, and it's important to have some of the mathematics down so we can understand the making of business decisions. For example, when it comes to calculating single sums, what are we talking about? Well, we're talking about the future value of a single sum. What will be the value of investing or lending money today at 6% or 7% or 2%? What will be its value of the money 10 years from now or 20 years from now when the money has been paid off by the borrower? So what will we have accomplished? If we give somebody money today and they pay us back 10 years from now, how much will they have to pay us back? Also, we can use this future value of a single sum to help make a decision on business. Suppose you got an extra $100,000 lying around doing nothing. Well, that would be nice. And what you're trying to do is whether you should invest it in a fixed and determinable investment, that is a loan with an interest factor for the time value use of your money, or expand your business. If you would know how much the $100,000 will grow if you invest it for 5 years at 4%, and compared that to your projection of what your money will make with a business expansion after 5 years, you can decide, do we expand the business? Is it worth it? Or do we simply invest for 5 years at 4%. So you can compare two what-if scenarios. What if we expand the business? What kind of rate of return will our money get us versus investing it? This is the old-fashioned way of how you compute the time value of money, the future time value of money, using tables. This table would be labeled future value, and we just don't have the label here, but that's what it would be labeled, future value table. And using this table, we're able to compute how much a dollar today will be worth 5 years from now at 4%. The way we use the table is we look at the number of periods involved, in this case 5 years, what's the interest rate, 4%, and we simply match where the two meet. This factor, this 1.21665, is multiplied times the amount of present money put into the investment to see what the future value will be of the present money put down. So we presently put in 100,000, we multiply it by 1.21665, and we come up with the future value, 121,665. That's what it'll be worth 5 years from now if it earns 4% compounded annually. By the way, back to this concept of compounded interest. The concept of compounded interest, just to elaborate, is really, so compounded interest is really saying that it's interest on interest, because when we do the compounding, we're adding interest to the principal, and then the interest factor is taken on the combination of the two. So it's interest on interest. And we should actually know that it means the following. And if you don't follow what this following statement says and why it's true, go to the text, go to Wikipedia, go to the internet, do a little Google search to understand compound interest. And this is what you should understand. That compounding interest on an annual basis is better than simple interest, that's for sure. But compounding quarterly is better than compounding annually. And compounding monthly is better than compounding quarterly. Compounding weekly is better than compounding monthly. And compounding daily is probably the best of all. And if that's not clear to you, then you need to expound upon your reading background to see why that's true. Why is it that the more we compound, the more value that interest rate is? The interest rate doesn't change, by the way. It simply stays the same, but the compounding creates more interest for our money. Okay, what if we wanted to know the opposite of the future value? What if we wanted to say, well, we want to buy a car in 2 years. Maybe 4,000 isn't the kind of car I'm looking for. Maybe we want to say 40,000, but let's stay with 4,000 for now. Yeah, 40,000 or 400,000. We want 40,000 or 4,000 in 2 years. Stay with the example here. We want 4,000 in 2 years to buy, let's say, a used car. How much do we need to put in the bank today if we can earn 5% on our money? The bank or a borrower is saying, I'll pay you 5% on your money. How much would we need to give the borrower in order to have 4,000 2 years from now at 5%? This is just the opposite of this table. It's the inverse. If this is the future value, the inverse of this table, and there is a table for it doing all the inverse calculation for you, the inverse is what we call the present value. So this is really, at this point, what we're really looking for is the present value of a future amount. We know what the future amount is. We project what the future amount should be. We project it should be $4,000. What do we need to invest today in order to have $4,000 2 years from now? The answer is going to turn out to be this factor, the inverse factor of a future value. So this is a present value factor multiplied by the future amount that we want, and we get the present value. This is actually the present value. These symbols or these initials you should become familiar with. Present value, future value. N in formula stands for the number of periods. How long will the money stay in? in terms of years or months, and I is the interest rate, of course. The interest rate. Here is the present value table, which does the inverse calculations for you. And if we're going to invest for 2 years at 4%, it's 5%. At 5%, this is the factor we use to figure the present value. And it works for any sum of money. It doesn't have to be $1. It could be 100,000. It could be any dollar amount. It works for that. And we're going to hold here and come back and start annuities in the next session.